section, 9.1, we're going to add and subtract polynomials today. But the first thing, you have a bunch of vocabulary that you need to know what it is that I am saying. And so our first word that we have up here is monomial. You guys all know the word mono means one. So a monomial is talking about one term. It can be a number, it can be a variable, it can be a product of numbers and one or more variables that have whole number exponents. Whole number exponents means no fractions, no negatives. So it can be a number, a variable, a product of a number and of one or more variables with whole number exponents. The degree of a polynomial talks about the sum of the exponents of the variables in that monomial. So let's put up an example of what we're talking about here. We could have 2 is a monomial. X times y is a monomial. 2xy is a monomial. 2xy to the third is a monomial. Notice that there is no addition or subtraction signs in there at this time. I could even have a negative 2xy. Notice the exponents are not negative, the exponents are not fractions, the exponents are positive numbers, whole numbers, and it's either a number, a constant, or the multiplication of that variable and a constant together. The degree of this monomial, all right, the degree of this negative 2xy. What is the exponent on the x?
1.
What's the exponent on the y?
1.
What's 1 plus 1?
2.
So the degree of that particular monomial is 2. How about the degree of this monomial?
4.
What's the degree on the x?
1.
And the degree on the y?
3.
Okay, so the 4 is appropriate. How about the degree on this one?
2.
2. How about the degree on this one?
2. 1.
Some of you may have read ahead down here. Constants have a degree of 0. So this one actually has a degree of 0. It's only the exponents on the variables. Is there any variables sitting here with x?
No.
No. So therefore, that's why it's going to be a 0. And guess what? 0 does not have a degree. So can't give a degree to 0. All right. Any questions there so far? And the next thing that we need to look at here is just determining what the degree is on these different monomials that I've put up here. I'm going to give you just a moment to talk to your partner and come up with the answers to these 4, and we'll get it up here in just one. All right, Josh, how about the first one? What do you have for the degree on the first one, you and your partner? 0. How about the second one, please? Austin. Second one does not have a degree of 3. Look at the exponents on the variable. Can you help him out at all, please? Grant?
1.
1. There's a 1 here, so we're going to have a degree of 1. You with me there, Austin? It's the exponent on the variable. The variable has a 1. Done. Does that make sense to you? All righty. The next one, please. Michael.
3.
That one has 3 because we have a 1 on the A and a 2 on the B. We have to add those together. And the last one, please. Allie? 5. Right, sitting right there. I'll write out plain sight for you. Jake?
I was just wondering, why wouldn't you, since the 2 has a 0, since it's a constant, you wouldn't divide 3 divided by 0?
No. Remember, our definition is degree is the sum of the exponents on the variables. Forget about the constants.
All right.
Okay? Anybody else? Let's go on, please, here. Why is 5 plus x not a monomial? Why is 5 plus x not a monomial? Hayden? Okay, it's not a product. Okay, any other reason? Jack?
It has addition.
Has addition. Okay. As addition. All right, especially because it is addition. There are two terms up there, so it's not a monomial, meaning one term only. Why is 2 over n not a monomial? Why is 2 over n not a monomial? Go ahead, Spencer.
It has division.
It has. I can have division. I go back here, right here. I got division. I have division. This is a monomial. I'm going to tell you that it is. But why would this one not be? Not because it has division. Not just because it has division. Okay, Andrew?
Because there's no numerator.
Remember back here that this is a monomial. There are no variables in the numerator. It's just a constant. Okay, Michael?
0.
If n were equal to 0, we'd have a tough time, but there's no, that's not the reason it's not a monomial. Harrison?
You have a variable in the denominator?
We cannot have a variable in the denominator. Okay, now think about this. What if I were to write this with the variable in the numerator? What would the exponent have to be? -1. Good job. -1. And can I have negative exponents?
No.
No. So no variables in the denominator. Thus also no negative exponents. If we move that n up to the top, it would become 2 times n to the negative first power, and I can't have exponents with negative I can't have variables with negative exponents. They can only be whole numbers. Jake?
What if it was like 4 to the -2nd? Would that work?
4 to the -2nd, remember, I'm only talking about variables and their exponents.
Like n to the -2nd.
If n to the -2nd is in the denominator, when you bring it up, it becomes n to the +2nd, right?
Yeah.
So you wouldn't have it sitting in the denominator because you don't have any negative exponents left.
Alright.
Okay? All right. Adam,
Oh wait, okay.
why is 4 to the a not a monomial, please? Why is it not a monomial? Rachel?
Your power can't be a variable.
There you go. No exponents as variables. Because that exponent could be there for a fraction, it could be a negative number, we don't want any of that. And how about x to the -1st power? Why is that not a monomial? Josh?
No negative exponents.
No negative exponents. All right. Any questions there? Adam?
Can you have a negative exponent on a constant?
Yes. Anybody else? All right, let's go on to the next one then. Polynomials. They are, what does poly mean? Many, yes. So a polynomial is going to be either a monomial or a sum of monomials. Think of the word polynomial as the great big umbrella name. You know, the one that's like covers everything. Do we have the word triangles? And underneath it, we know there are different kinds of triangles, right? Well, we have the big umbrella name, polynomial, and we know there are different kinds of polynomials. One of the kinds of polynomials is a monomial. Okay. And then we'll talk about a couple other kinds of polynomials here in just a moment. But a polynomial is kind of like the in general term. So it can be a monomial, or it's going to be a sum of monomials. Each one of them is called a term. You've heard me use the word term before this year. Add the terms together, get your like terms together. You've heard me say that. The degree of the polynomial here, whoops, let's try that again. The degree of the polynomial is actually the greatest degree of all the terms. So you have to find out what the degree of each term is, and it's whichever one is the biggest. That's going to be the degree of the polynomial. And finally, we have the leading coefficient. Coefficient is that number that sits in front of the variables. And the leading coefficient is whichever term has the highest degree. That number sitting in front of the variables is your leading coefficient. You're going to hear me using these words throughout the chapter. I want to make sure that you have some idea of what they are talking about. We're going to go through these words here in just a moment with some examples. Any questions so far? Leading coefficient. Which number up here do you think is the leading coefficient? Remember, it is the number in front of the term that has the highest degree. What do you think, Jack?
X to the third.
Well, the x to the third, this term right here is the highest degree, right? So what's the leading coefficient?
2x to the third.
Just the 2. Leading coefficient is just the 2. It's the number in front of the variable with the highest degree. The leading coefficient is just the 2. So you should be looking at just that number. We have many degrees up here. Okay, we have degree of 3, we have a degree of 2, we have a degree of what here?
1.
1, very good. And what about the degree on this guy?
0.
0. So this has a degree of 1, this has a degree of 0, okay? Not 12 to the 0 power, it's just we're talking about the degree itself. Question, Michael?
You would have like x to the fourth, would your leading coefficient be 1 then?
Yes. Whichever term has the largest degree, the number in front of the variable is your leading coefficient. And constant term is talking about the number that doesn't have a variable at all with it. That would be your 12. Your constant term is the 12. Because it never changes. It's always 12. There's no variable attached to it. So the other coefficients here, you can have a 1 as a coefficient, a -5 as a coefficient. The 2 is the leading coefficient. It's on the term with the highest degree. With me? We're going to rewrite this expression down here so that the exponents decrease from left to right. Would you take a moment and just rewrite that so it goes from highest degree down to lowest degree? Okay. Cassidy, tell me how to write this from highest degree down to lowest degree. Oh, you're not sure. Okay. All right. That's all right. Brooke, how about you? What do you and your partner come up with?
Negative x to the third plus 15 x plus 3.
All right. I like that. If you had what Brooke just gave me, negative x to the third plus 15x plus 3x, highest degree down to lowest degree, then you have the right thing there. So, what is the degree of each term? What's the degree of this term, ladies and gentlemen? 3. How about this one?
1.
How about this one?
0.
Cool. What's the degree of the polynomial then?
4.
Oh, wait. 3. 4.
Which term has the highest degree? The first, second, or third one?
First.
The first one. What's its degree?
3.
3. Then the degree of the polynomial is 3. Whichever term has the highest degree, that is the degree of the polynomial. You know, in this chapter, we're going to start talking about things like quadratics and cubics and quartics. And that's talking about the degree of the polynomial. We're going to do a lot of equations that have a degree of 2 quadratics. Goes along with my lovely song I'll sing at another time. Cubics is a degree of 3. That's what this is. This is a cubic equation. Its highest degree is a 3. What's the leading coefficient on this particular problem then? Jake? -1. It's this number right in front here, -1, on that term that has the highest degree. Okay, what's the constant, class? The 3. Yeah. Questions? Let's keep moving here then. A binomial, guess what, is a polynomial with 2 terms. Bi meaning 2. How many wheels does a bicycle have? 2. How many wheels does a tricycle have? 3. Yeah, those prefixes mean something. Ooh, trinomial then must be a polynomial with 3 terms. Trinomial. Binomial 2. Trinomial 3. Monomial 1. Polynomial? Many. It's 1 or more, yes. All right, so how about a 4 terms? Any name for a 4 term? Nice try, but no, there's no name for it. Nice try. Okay. Poly, mono, bi, and tri. That's it. Next, I want you to tell whether this expression is a polynomial. If it is, you're going to find the degree and classify it as a monomial, polynomial, binomial, trinomial type idea. Or if it's not, you have to tell why it's not a polynomial. Talk to your neighbor real quick here. Okay, ladies, gentlemen. 5xy squared. First of all, is it a polynomial, yes or no? Jack?
Yes.
Okay, Jack says yes, it's a polynomial. What kind then?
Monomial.
It is a monomial. 1 term. Are there any addition or subtraction signs in this problem? No, that's a monomial. There's 1 term. It has a whole bunch of factors in there, but it's 1 term.
But doesn't the x have 1 on it?
It's a term. 5xy squared altogether is 1 term. Okay? Remember, the monomial is a constant multiplied by variables. It's all multiplication, no addition, no subtraction. What is the degree of that monomial then, please? The degree, Hayden?
3.
The degree is 3. Okay? And that's looking at the exponents. How about 3a to the 5th? Is it a polynomial? What do you say, Spencer?
No,
Why not?
because it has negative exponents.
Ooh, negative exponents. Bad things to have. Okay, so look at the 3rd one then. Is it a polynomial? Yes or no? Let me say, Tyler.
Yes.
Yes, what kind of a polynomial do you say it is?
Trinomial.
It is a trinomial. Remember, we've got 3. 1, 2, 3 terms there. They are separated by what things? Addition signs, because this negative sign really goes along with the x. So there's an addition sign there, we just can't see it. It looks like a subtraction sign right now. Okay, so you keep working away on your terms. You go x to the 4th. Oops, I hit an addition sign. That was my first term. 3x to the 3rd. Oops, I hit another addition sign. Negative x. There's my other term. What's the degree on that particular polynomial, please? The degree, Michael? 8? No, it is not. No, it is not. Allie? It is 4. Whatever term has the highest degree is the degree of the polynomial. Whatever term has the highest degree, that is the degree of the polynomial. Well, a monomial is only 1 term, so you take the degree of the term itself. Okay? 9 over m, is it a polynomial? Is it a polynomial? Brad?
No,
Why not?
you have a variable in the denominator.
No variable in denominator. Good. And the last one, is it a polynomial? Okay, is it a polynomial? Jake?
Yes, it's a binomial.
It's a binomial. Okay, there are 2 terms there. We see term 1 and term 2. And what is the degree then of our polynomial that we have? The degree. Adam?
6.
It is 6. Yes. Look at your exponents right there. Okay, 1 plus 5 gives you 6. Questions there? All right, let's go on. Now we get to actually add polynomials. You guys are going to find this very easy. Remember when we talked about adding like terms way back when? Yeah, we're adding like terms. I got negative 2x squared plus 3x minus x cubed. Let's rewrite that so that we're from highest degree to lowest degree and get things lined up. I'm going to pause for a second to write so it looks better. When you write the second one, you need to put the terms underneath each other so that you got squares underneath each other's and cubes underneath each other's. Notice I have that minus 12 sitting out by itself and 3x is sitting by itself because I don't have any other x terms. I don't have any other constants. And then we can add them up. What do you add when you add terms? You add the coefficients. You add the coefficients. This is like saying a negative apple and a positive apple. How many apples do I have if I have a negative and a positive?
0.
0. So the x to the third power here, those cancel out completely because I got a negative 1 and a positive 1. Done on that one. Then I've got negative 2 and positive 3 x squared. What does that give us?
X squared.
Okay, 1x squared, which I just write as x squared. I don't have to put the 1. I may if I want to, but I don't have to. Then 3x plus 0 gives us 3x. Negative 12 plus 0 gives us negative 12. Do not change the exponents. You're not multiplying them. You are adding terms. Apple plus an apple gives you apples. Orange plus an orange gives you oranges. Start putting apples and oranges together and you get fruit salad.
Yummy, yummy.
And it might be very yummy, but it makes no sense if I'm trying to put it into a mathematical equation. Okay? So don't put, don't put hippopotamuses and giraffes in the same place together. Only hippopotamuses over here and giraffes over here, please. Yes.
Why does the 2x cancel out?
The x squared.
Or yeah, the x squared.
Because if I were to say to you, I have 3 electrons here and 2 negative electrons, when I put those together, don't I end up with just 1 electron that's positive? I don't end up with the electrons going whoosh and I get 1 what? Do you understand what I mean by that?
Yeah.
Fabulous. I got to have a label there. I got to have a label. You got $3 in your bank account. You have a negative $2 in your other bank account. When you put it together, you really have a total of $1. Okay, it's still $1. Any other questions? Why don't you put this one together? When you start adding, be very careful to look, what are my degrees as I'm going along, and have things in order for yourself. Notice that I put this minus 4 over here a little ways because it was constant because I had a positive x sitting there that I needed to get lined up. Do you have to go vertically? No, you don't. There are some of you who could probably look up here and go 4 plus 1. I know that I'm going to get 5, right? 5x to the third. And then you could probably look and say 2 and negative 3 gives me how much? Negative 1. So I got negative 1x squared here. Plus, then I've got an x and my minus 4. So I have my minus 1 and my 5 here. I now have a new polynomial as my answer. Okay? I added 2 trinomials together and came up with a polynomial, and that answer is correct up there. Andrew?
What if in like the top one there is another, like a positive 4x squared?
Another 4x squared, you just add it on. Add the coefficients together.
Okay.
Okay? Jake?
Since there's, wouldn't the x and x squared be like terms?
No, x and x squared are not like terms. They have different exponents. They have the same variable, but they have different exponents.
Okay.
Okay? Grant?
You need to have the negative 1 more than x squared.
No, you do not. You can write it like this, Grant. 5x cubed minus x squared plus x minus 4. You do not need a negative 1. You do need a negative sign, though. Okay, anybody else? Fabulous. Let's go on here. Subtracting polynomials.
Are we gonna subtract?
Oh, of course. Ladies and gentlemen, when there's a minus sign out here, what does that mean that you're going to have to do?
Well,
You're going to have, what number is sitting out here?
1.
A -1. So really, you are applying a negative sign, aren't you, inside there? The distributive property. So we'd have 2c squared minus 8 over here. And this 3c squared, how are we going to write it? Negative 3c squared. And the negative 4c gets written as
positive.
plus 4c, and the positive 1 gets written as
Negative.
minus 1. And now I just changed my subtraction problem into addition problem. How cool. Now I can just add the coefficients together. Ooh, so on this first one, what do I get for my term? Negative c squared. Then I get plus 4c. And finally,
Negative minus 9.
minus 9. Put a box around your answer, and you are finished with that one. Isn't that cool? Just change the subtraction problems to addition. You're done. They're all addition problems. That's pretty cool. Can you all add with the help of a calculator?
Oh,
Yeah, you should be able to. Don't change the exponents on the variables. That's something that kids do once in a while. What's wrong? So please, don't do something wrong. Do we need to do another one? No? All righty. Then we're going to go to this last one. During the period 1999 to 2005, the number of hours an individual person watched broadcast television, B, and cable and satellite television, C, can be modeled by these two equations that I have right here. T is the number of years since 1999. How many hours did people watch television in 2002? Good question. Let's see. Some watched broadcasts, some watched cable and satellite. And I want to know how many people watch television. What am I going to have to do to these two equations? Add them. Well, let's add them up right now. 2.8 and a -5. Allie? Negative 2.2 t squared. Negative 35 and a positive 80. Positive 45? You guys agree with that? Okay. 879 plus 712. 1591?
Yeah.
Okay. So that's the two added together. But I want to know how many hours people are watching television in 2002. How many years after 1999 was the year 2002? 3. So you put a 3 in every time you see a t. So we get negative 2.2 times 3 squared plus 45 times 3 plus 1591. I hope you have your calculators, because I know 3 squared is 9. I need 9 times negative 2.2. Negative 19 point what? 8. And now I need 45 times 3. 100 how much? 35 plus 1591. Now I need these 3 numbers added together.
1726.
1726. You guys agree with that?
Wait, no, that is not right.
No? Okay.
It's like 5 numbers.
1706.2.
1706.2. You guys agree with that?
Yeah.
Okay, and that would be, what would our label be? Hours. 1706.2 hours in the whole year for an individual person.
Okay.
How many days are there in a year? 365. So take 1706.2 divided by 365.
4 hours.
4 hours a day?
Almost 4
4.4 2/3 hours a day? Wow, when do you go to school? All right.
When you feel like it.
a low